So I'll be focusing for next, I think, half an hour or so on what is going on in the world. So we know mostly what is happening in LLM space. Everybody who is working on AI in one or the other way is using language capabilities of these transformer enabled models. But there is so much happening beyond language as well, which is in vision space, in audio space, etc. So this is more of introduction to what is going on, and I'll be just talking about what is the world doing and what are the new opportunities that are opening up in terms of what was not possible for tech just like 1 or 2 years ago, and with these new VLMs, vision language models, what is possible now and what kind of new application we'll see, etc. So it will be more about that. I won't be going into anything that we are doing at Flightbase. So we'll be sharing some of that in the later sessions. SRV, do you want to give a brief overview of what is going to happen throughout the session?
Right, so we'll start with the state-of-the-art session that Dheeraj will have for around 30 to 45 minutes. Let's keep the engagement going. So the more questions you guys ask, Dheeraj will be more than happy to kind of answer any questions that you have. And then once that session gets over, we'll take around 5 minutes of breather, and then we'll go on. So we'll talk about how we have used these models to build our own video analytics sort of a pipeline. And the entire journey of the discovery of how we kind of tried out multiple different VLMs, what worked, what did not, and then at the very end we'll do a very short hands-on sort of a session. So I hope a lot of you guys have brought your laptop, so we'll do a very quick hands-on session with VLM, with a vector database as well.
Okay, thank you, SRV. So I'll keep switching between English and Hindi. Is that okay? Hindi, everybody understands? Okay, thank you. So, okay, not sure how audible is this. Like, is it okay? Not clear. Okay, I'll have to hold it. ठीक है. हाँ, कोई बात नहीं. It's okay. I'm not typing anything in now. So, ठीक है. तो कितने लोगों ने यहाँ पे VLMs के बारे में जानते हैं? विजन लैंग्वेज मॉडल्स देखा है कुछ, तो क्या करते हैं वगैरह? यस, क्या होता है? एनी गेस? लाइक आप लोग बता सकते हो? एनीबॉडी?
So it basically understands video or stream frame by frame, trying to make sense out of it. We can apply analytics, we can apply transformer models. It's a transformer model of course, and we can make a sense out of every frame what's happening, and together it gives you output what is really happening. And based on your expectations you can write your code and it gives you that.
सही है. और
I will just tell how the vision language model works. So it basically maps your image into a vector database at a pixel level. So each pixel level it's a kind of embeddings it will generate for the embeddings for the pixel. Then we combine 4 pixels into a single part, and again at each level the number of combined pixels will increase. In that way it works and it analyzes that image.
Okay, I think if you could pass the mic behind you. Yeah, thank you.
Hello. Yeah. So, like I've not worked specifically on vision language model, but I've worked like with APIs. So what I've noticed is we can provide any image. If it's a video, we can extract the frames out of it and provide that frame to the model, and we can prompt it to describe to get the insights out of that image. So like we can say like it will create a description of that image, and then we can chat with that description. That
Interesting. Okay. ठीक है. So what we'll do is I'll show you some examples of what vision language models can do today, and like some of these examples are slightly old in terms of like they're 3 months old or something like that, but that will give you a good idea about what is the capability that is unlocking, and then we'll get into a little bit of okay how that works, etc. Like just very basic. So this was a vision language model that was released, I think about, this is a model by Qwen. Everybody knows Qwen models, right? Just trying to find. Okay. So this is a Qwen 2.5 VL model. So right now Qwen 3 is out, but the vision language model of Qwen 3 series is not out yet. This was released in January, although it is quite good model even today, and there are a lot of other models. We'll see what they can do, etc. So one of the most important thing is they can understand things visually, etc. and they can still do tool calling and all of that. Everybody knows tool calling in models today, right? So in all the latest models, you can ask a model, okay, given this situation, what is the workflow that you would like to do, and what tools would you like to call? Tools could be bash, or it could be like a bash script, or it could be a URL fetch, something like that, doesn't matter. So all of regular LLMs, they can do tool calling. These models also can do tool calling, okay? And they are able of, right now, some of the models today, they can even do localization within that image or video where that object is, at what timestamp that object is, etc. So I'll show you some images and videos as an examples that will paint a picture in your mind in terms of what these VLMs can do actually, okay? So example, like so what we'll do is whenever we see something like this, we will also try to draw analogies with what is happening in the LLM space, okay? So in LLM space, if you ask ChatGPT or anything today, what is the seventh wonder in the world, then it will say Taj Mahal, because it has been trained on so much data. It remembers lot of things. It also does some kind of first level, second level reasoning on that data as well, and then it can give you that, right? If you ask ChatGPT, give me directions to seventh wonder of world, it knows directions, and it can also figure out, it is probably not trained on directions to seventh wonder of the world from Delhi, but it can figure out, okay, seventh wonder is Taj Mahal and then directions, etc. So they can do basic reasoning. They also have basic memory. So in terms of these vision language model, what are these attractions? Please give their names in Chinese and English, and then it gives top left Great Pyramids of Gaza, etc., etc. So what you will see is these models and remember things as well, not to it's not a photo memory or something, but they can remember some of these things, that these are these wonders, etc. And they can also give, then they can also do reasoning on top of that. Precise object grounding. Now this is object detection mixed with reasoning. So in this prompt, if you look at the prompt, detect all motorcyclists in the image and return their locations in the form of coordinates. The format output should be bounding box, label motorcyclist, sub label wearing helmet or not wearing helmet, okay? And it will not only give all the motorcyclists, but also, okay, helmet or not helmet. The spelling is, okay, these are Chinese guys, so I don't think they care about English spellings, but finally it is able to give you what is going on, and within that scene it is also doing that first level reasoning, who is wearing helmet or not. There are some even more interesting examples. Identify basketball players and detect the key points of their heads and hands, returning them in the form of points. The primary label is player's name, and the secondary labels include left hand, right hand and head. So it says LeBron James head, LeBron James right hand, LeBron James left hand. So I don't think it is trained on any data where LeBron James right hand and left hand. It understands LeBron James because it can identify from memory, because there are so many images on internet about LeBron James. So now it can recognize LeBron James for sure, but left hand, right hand, that is reasoning that it is doing on its own, right? Now if you give another person and tell, okay, show right hand, his left hand, they will do it, right? So it's not just like old deep learning models where it just does basic pattern recognition. So how many people here worked with some of the other deep learning models in the past, YOLO and all of that? Raise of hand. Okay. Okay, at least 2-3 people who have worked with this. So you would recognize stark differences in terms of you had to train on a particular class. You had to train on that particular feature. And then out of those examples, so many examples, it will start do some pattern recognition. But then there would be no like any reasoning or anything. You would have to do that in your own code. Now these models can do that. Like there are some even more interesting examples. Locate every cake. Sorry. Locate every cake and describe their features. Output the bounding box coordinates. So each cake with white frosting and eyes, white frosting and colorful sprinkles, etc. for each of cakes. Now, of course, they are doing amazing wonders in terms of OCR, optical character recognition, right? So right now there is a big fight going on between VLM approaches to OCR versus the traditional approaches to OCR, which was using computer vision and all of that. So examples like this, multilingual, lot of icons, etc. These are able to give everything in terms of what is going on. Reading the receipt or something like that, and it is just giving, okay, this is the text. Now you feed this to some LLM and it can also do something on top of this. And more VLMs are coming today which are doing a lot of reasoning themselves. So you can give this and ask it to maybe tell me how much tax I am paying. Should I be any of these taxes? For example, if you show an Indian hotel receipt and let's say you want to ask it which of these I should not be paying, then it might tell, okay, service charge is optional. Do you want to go and like get the service charge cancelled if you want to do that? So even that kind of reasoning is possible. So there is so much in OCR space. Then video comprehension ability. Now this is very interesting. So this is a small video where and then they ask this VLM to describe what is going on. It describes in Chinese. The object pictured is a traditional Chinese lion dance prop, especially a small lion head, Chinese culture and like everything around that. It is able to understand what is going on in this video. This is a full match. This is a 1 hour 13-minute video of a full match.
So it's Venus v Serena, sister v sister for the 2017 Australian Open title. Venus v sister. The Q players are ready.
Okay.
Ready, play.
So the entire match is like about 1 hour 13 minutes. Lot of things happen, etc. And the model is asked, could you provide a comprehensive overview of the competition's progress? The model analyzes entire video. It gives this output. Can you guys read it? Well, I'll just read few things. The video captures an intense, The video captures an intense and highly competitive tennis match between Venus Williams and Serena Williams, two renowned professional tennis players during Australian Open in Melbourne. So it is able to not only look at the video, it also understands audio. So this particular model is video plus audio input. So they can understand audio as well. So whatever the commentary guy is like saying, it is listening to that. The match is set on a vibrant blue hard court with iconic Melbourne branding, etc., etc. Then match progress, initial stages, mid-game dynamics, key moments, later stages, what happens, final stages, audience and atmosphere and conclusion, etc. After analyzing all of that, did we have capability like this to understand videos like this or images as we saw previously, let's say 1 year ago? Have you seen any tech that understood visual world, the world as humans see, as we perceive that visual world, did we have similar abilities? What do you think?
We used to have transcription.
Audio transcription.
Audio transcription. Based on that, we were able to get some insights.
Right.
That was there.
Right. But nothing that ever touched the video space, right? And even in audio, it was quite, compared to what we can do in audio as human society, audio transcription, I think that was also very basic. Only few languages were supported to a decent level, and then also accent and all of that mattered. So, but today VLMs can, other models can also very easily understand all of that. I'll show you a very interesting example here in terms of video understanding.
I think with video it has a context understanding more to the audio.
Yes.
So it makes a lot of sense what he sees and what's being spoken.
So audio transcription is like, let's say you are hearing a cricket match on radio and versus you are watching the match.
It's a different experience.
Yes. So you would still be listening to the commentary, but you are also watching. So the perception is very different in both cases. So this is an example. Localized series of activity events in the video. Output the start and end timestamp for each event and describe each event with sentence. Provide the result in JSON format, etc. Okay. So this is a video where they are making some recipe.
So sieht ein Brisket aus, wenn es aus dem Dutch-Ofen kommt. Das glaubt ihr nicht. Na dann bleibt mal dran. Denn es ist Zeit, den Grill anzuschmeißen. Schon seit längerem spiele ich mit dem Gedanken.
So it's a food recipe.
Und just letztes Wochenende war es so. Dann selber in Seiten, die 0 auf 5, kein Mord, Dutch-Ofen.
So they do lot of stuff, lot of cooking here, and then it will give all the activity. A person removes a piece of meat from its packaging and cuts off the fat. We'll pick a random one. The seasoned meat is placed on a grill. This is from 128 to 136. So we'll start from 126. It is placed on the grill. It found that exact timestamp and showed exactly where that is. Let's do one more. A rack is placed inside the pot and the meat is set on top. 209. This rack is set inside and the meat is placed on that. So it is able to understand video as well. And now what you will see, lot of application. So these are the models that are enabling lot of applications in terms of computer use. Yeah.
Is this something similar which YouTube also does, where it puts timestamp in the videos?
So lot of these models are being used for that now, where it will give you automatically timestamp in that video. What YouTube did from many years is audio transcription. They did not understand video. There was no way to understand videos that well. So whatever YouTube did was based on audio and any other cues where the user would put in that transcript, etc. But it was not done using VLMs. But now more and more it is being done in using. I'm not sure if YouTube is doing it yet with VLMs, but their Gemini models are also quite good. Google's models of Gemini 2.5 Pro, and I think those models are quite good at visual understanding. So these are all called multimodal models. They don't have one modality. Like one modality is language, another modality is sound, another modality is vision. So these models are multimodal, including ChatGPT. ChatGPT also understands vision in terms of you can send in images. I haven't tried videos actually, but I don't know if they can do that.
But live video it can understand.
Live video, ChatGPT, yes, GPT models they can understand because ChatGPT has that live video interaction. How many of you have done live video interaction with ChatGPT yet? Gemini, shown it around and spoke with it. How many of you have done that with any model, ChatGPT, Gemini, anything? Raise of hand. Oh, very few people. It has been available for about a year now. So at least like 7-8 months it has been there. And it is quite good today. So you have to just use mobile app and And I think ChatGPT today understands also, you can also share screen. And then have you tried sharing the screen with ChatGPT or Copilot or anything? Gemini, okay. So you are sending screenshots, right? So all these models can directly understand video as well. So I'll show a very rapid demonstration. Hi, how are you?
Hey there, I'm doing well, and absolutely, I'll just cut straight to it and keep things forward looking like you asked.
Is anybody not okay with having their video on with AI? Okay, everybody's okay. So we are here with the AI at Flight Base session today morning, and this is the office. Do you recognize what is there on that terrace?
All right, absolutely, straight to it. I can see that you've got a nice open terrace area there. It looks like a bit of a rooftop space. Some potted plants maybe along the side, and it's probably just a casual spot you're using. So yeah, I recognize it as a nice chill area on your office terrace. Let's just keep things moving forward from here.
Okay, what is this that you see?
All right, let me tell it like it is. That looks like a drone docking station or some.
That's what I had shown, right? There is some latency in terms of the docking station that I showed from outside. It recognizes that there is a docking station there. I can maybe ask for, based on what you see, which office is this? What company office is this?
All right, let's be direct. From what I'm seeing, it's pretty clear. We're at Flight Base. I can see the Flight Cafe sign in the background, and it lines up exactly with what you mentioned. So yeah, that's the Flight Base office without a doubt. Let's keep it straightforward and forward thinking from here.
So based on Flight Cafe sign, it can tell it is at Flight Base because it has so much material around Flight Base and what is there at Flight Base, etc. So this is vision plus LLM plus. That's like there is a real-time vision model that is doing all of this. So that is the level of ability, and of course that's with OpenAI models, and these are a lot of open source models that where the ability also lies with everybody. Okay, so apart from this, I'll show you few other interesting things that these models can do. This is from Meta, where they are going into spatially understanding what is going on. So it asked for table in front of the couch. There are a lot of tables in this scenario, in this overall 3D map. Water bottle on top of the counter. Why is it saying specifically on top of counter? Because this model can actually understand that spatial relationship between various objects, etc. So this is beyond just 2D vision. It is in the 3D model space. It is able to understand. So there is a cool demo on this page where you can go and try that as well. So this is a very difficult task to any existing computer vision deep learning techniques, that person asked in this video, how many fudges did the person transfer to bag? It tells 5, looking at the video. So that's very interesting, like a ability that was not there. So it was able to tell where the dog is looking at, and the dog returned to the person who threw the ball, etc., etc. That is very interesting understanding. So the reason I wanted to show you all of this is primarily because there is so much research happening in this direction. Lot of capabilities already available. Whatever I showed you using ChatGPT live video discussion, you can ask it for anything. I have tried repairing my car using this, works very well. Just show it engine and like, okay, this is what is happening, tell me what is the problem, or ask for any parts and it will immediately tell you, okay, what is this like, looking at that, what are those parts, etc. It has very good understanding already of the world around us. And so you can just start showing it and then it will tell you, like, ask for this camera, can you explain me the controls of this camera or something like that, I want to start using it. So all of this ability is already available as a user, and then as a developer, now there are a lot of applications that are coming in which are leveraging all this ability. So one of them, clear one, is computer use. Computer use where all these models can understand the screen as we humans do. So there is a lot of course, automation happening in, last time we saw, I think, Chrome MCP, right? Chrome MCP, and the other one was, P से क्या था? Chrome वाला भाई उसका पहले का Playwright, right? All of them have a very different understanding of the page. They look at the content on the page, but all these models enable this computer use agents to look at the web pages as humans see, visually, right? And understand, because most of the web pages are designed for humans anyway. And if they can understand using like vision, then they can understand how to navigate, etc., etc. So there is a lot of interesting applications coming in there. Apart from this, इनके नीचे में जो बेस टेक्नोलॉजी है, तो those are LLMs, मतलब large language models. Why are they called large? LLMs में large कहाँ से आया पता है? It's primarily because of उनका parameter size and then lot of training data that they give. Then it starts understanding, because of based on that language, it starts understanding the world around us, and it has all those LLMs learn representing the world around us, the reality around us in language, right? It is like a blind person. Blind people, they can describe the world in language, in touch, in other senses, but not the vision, right? All these models, the VLMs or vision language models, these are called multimodal language models, or like there are like lot of new terms. There are like all perceiving, all kind of senses, etc. They're like even like there are different categories of models, but these models can understand the world in many different modalities, and they can still make sense of everything. So humans, when we see something, if you are on the street and you're trying to take a right turn, do you talk to yourself that, okay, now that car is coming, now there is open space, now I can take right turn? No. Our brain understands the scene, does the reasoning visually in the same vision space and goes there, right? So similarly, all these models now are learning to represent reality in multiple modalities, languages, vision, like video, audio, etc., etc., and also do reasoning at the same time in those modalities. That is going to open lot of interesting technical applications which we did not see earlier. And one of the biggest industry that it is going to give boost to is robotics, because now it will not be about so much about software in the sense of digital systems. Last 20 years, one big industry that was that came up to rise was all the software industry, specifically to solve digital workflows, right? Payments, factories, within factories also, like everything that can happen on computers, right? That is the biggest industry that was there. Now that industry will shrink in its impact, because all of you know how fast AI is writing software, etc. New industries will open up, specifically in robotics, where now we will see a lot of real world applications where systems, machines, robots are able to interact with the world just as we do. And very likely, most of us sitting here will have to get into some of those applications, because that is the only frontier where there is not much work already done, right? All these models, they haven't yet understood how to perceive touch, right? If there is a sensor, like we can also, if I hold something like this, if I, let's say, go and hold a pillow, just from holding it, even if I'm asleep and if I hold a pillow, if there is dark and I hold a pillow, I know it is pillow, right? Even from touch, there is so much perception that we can do, and there is so much understanding we have around touch, around smell, around texture. If I like put something in my mouth, just by texture there are so many emotions and so many memories that can also come in my brain based on that, right? Similarly, to understand and perceive the world around us and to be able to truly have robots that can interact with the world just like we do, there is so much of research already happening, and we will all be building some of the applications in that direction as well, very likely. Because within digital space, like by digital, what I mean is where you don't interact physically with the world. Indirectly you can do, of course, like somebody like creates a task in, let's say, Jira. Of course, there is some person, Jira or ServiceNow, some person who is going to walk around and do some maintenance on some like equipment because there is a task there. But that's not a direct interaction. Now we will have software and robots and systems which will interact physically with the world. And this is a big new direction, like big new frontier that is opening. And that is why after AI, and due to actually AI, now robotics will get that pace. So a lot of people have spent a lot of time on designing hardware, but now it's all about what can that hardware go and do and interact and learn. So AI, one interesting analogy is AI has learned already whatever is in our books, right? You know how LLMs are trained, right? They are usually trained on lot of open public data. So LLMs could not have been around in 1990s or 80s. Why? Because उतना knowledge ही नहीं था उनको train करने के लिए. LLMs के अंदर में simple math is like whatever their transformers etc. model के अंदर में when you train it through so much data, massive amounts of data, then they start picking trends. And then they start picking like छोटा मोटा reasoning वगैरह उसके ऊपर में. And that is why LLMs are very successful because they were trained on so much data. 1980s, 90s में उतना data ही नहीं था, right? Now LLMs have learned to represent the world around us, understand the world around us in language quite decently. अभी भी हमारे वर्ल्ड का बहुत सारा नॉलेज जो इंसानों के पास होता है इज नॉट डॉक्यूमेंटेड नॉलेज. ये चौक के अंदर में क्या होता है, किसने डॉक्यूमेंट किया, इंडिया में ड्राइविंग करते कैसे है, ये डॉक्यूमेंटेड है क्या कहीं पे? अपने यहाँ पे एक गाड़ी अगर डाल रहा है दूसरे की गाड़ी सामने कैसे लगानी होती है, ये कहाँ डॉक्यूमेंटेड है? इसका कोई डॉक्यूमेंटेड कहीं पे कुछ है ही नहीं. इट इज़ ओनली डॉक्यूमेंटेड कि इंडिया में बहुत रैश ड्राइविंग होती है, लेकिन इंडिया में ड्राइव करना कैसे है इसके कोई डॉक्यूमेंटेड लेसन्स, बहुत सारे बड़े बड़े टेक्स्ट बुक्स, जिस टेक्स्ट बुक में हर एक सिनेरियो लैंग्वेज में लिखा होगा कि इसने इतनी गाड़ी आगे ली, मैंने 2 इंच आगे ली. यू कैनॉट डिस्क्राइब लॉट ऑफ फिजिकल इंटरेक्शंस इन लैंग्वेज एनीवे. आप मैच की कमेंट्री कितनी हो सकती है, मैच का हर एक डिटेल तो नहीं समझ सकता ना. इतना बड़ा सीन दिख रहा है, उसके अंदर ऑडियंस में ये लोग खड़े हैं, ये बैठा है, ये नाच रहा है, इतना कमेंट्री में आता है क्या? इतना सारा ऑडियो में डिस्क्राइब करना ही मुश्किल है. जो विजन में है वो विजन में ही है, जो ऑडियो में है वो ऑडियो में ही है, जो टेक्स्ट में जितना जा सकता है उतना ही रिप्रेजेंट हो सकता है. विच मीन्स एवरी न्यू मोडालिटी हैज़ लॉट ऑफ न्यू नॉलेज. और आज तक इंसानों का सबसे बड़ा नॉलेज इज इन टेक्स्ट. उसके बाद में कुछ है हमारी मूवीज़ और कुछ वीडियोज़, और इतने सारे लोगों ने अभी क्रिएटिव इकोनॉमी की वजह से बहुत सारे वीडियोज़ आए हैं. डिस्पाइट दैट देर इज सो मच इन विजन दैट इज़ नॉट अवेलेबल टुडे फॉर ट्रेनिंग. देर इज सो मच जो कि इंटरेक्शन से ही समझ में आता है. जब आप जाके फिजिकली इंटरेक्ट करते हो तब आपको समझ में आता है अरे ये मिक्सर जो है ना इसका बटन एक बार ऐसा करना पड़ता है तब चलता है. ये इंटरेक्शन से ही पता चलता है, राइट? देर इज सो मच सच नॉलेज. अभी कोई इंडस्ट्रीज़ के अंदर में इतने सारे प्लांट्स वगैरह होते हैं, तो उसके अंदर में जो एक्सपर्ट वर्कर्स होते हैं, जो एकदम एक्सपर्ट बहुत पुराने वर्कर्स जिनको सब कुछ पता है, दे नो कि इस मशीन के साथ कैसे ट्रीट करना है, इसको कब रिपेयर करना है, कब ये चल जाएगी. अभी इसका कोई डॉक्यूमेंटेड नॉलेज नहीं होता कहीं पे. ये सब कुछ आपको फिजिकल इंटरेक्शन से समझता है. तो किसी तो रोबोट को जाकर के जैसे आज इंसान इंटरेक्ट करते हैं वैसे उसको जाके इंटरेक्ट करना पड़ेगा, तब उसे वो चीज़ें समझेगी. सो अभी ह्यूमंस का ऐसा है ना, किसी ने लिखा हुआ बस हिस्ट्री एआई ने पढ़ लिया है, बट जो रोज़ हम लोग करते हैं वो काम अभी तक सीखा नहीं है. वो सीखने के अभी नए चैलेंजेस ओपन होंगे. दोज आर द अपॉर्चुनिटीज दैट आर ओपनिंग अप अदर देन, मतलब हर किसी को वही लग रहा है एआई आएगा सॉफ्टवेयर में, हम इंसान क्या करेंगे. इंसान अभी ये जाकर के सॉल्व करेंगे प्रॉब्लम कि रोबोट जाके इंटरेक्ट करेंगे कैसे वर्ल्ड के साथ में. रोबोट जाके अगर कुकिंग करेगा तो कुकिंग करते टाइम जैसे हम समझते हैं कि अरे वो तड़के का स्मेल ज़्यादा ही हो गया, जल तो नहीं गया मेरा तड़का. विजुअली नहीं, स्मेल से तू कैसे समझेगा कि तड़का जल रहा है. विजुअली दिखता है क्या तड़का जल रहा है करके नीचे में, बहुत बार समझेगा नहीं, लेकिन अगर साइड में हो, लेकिन कान के ऊपर में आए सुनाई भी देगा, स्मेल भी आएगा. तो देर आर लॉट ऑफ थिंग्स दैट आर robots still not able to do, and that is where the frontiers will open, rather than बस existing सॉफ्टवेयर को मैं अभी AI से बनाऊँ. थोड़े दिन बाद, मतलब अभी जिस तरीके से क्लाउड कोड के अंदर में अपडेट्स आ रहे हैं, अभी वो सब एजेंट्स वगैरह कुछ तो आ गए हैं, धीरे धीरे मतलब विद इन 1 year और एनीथिंग, मतलब बहुत सारे एप्लीकेशंस के लिए कोडर्स की ज़रूरत होगी ही नहीं, तो करेंगे क्या हम लोग फिर जा करके. सो दीज आर सम ऑफ द फ्रंटियर्स दैट आर ओपनिंग. दैट इज़ वाई आई वॉन्टेड टू शो कि किस डायरेक्शन में अभी रिसर्च हो रहा है एंड कहाँ पे अपॉर्चुनिटीज़ है. So happy to take any questions, just जिनके भी हो. Yes.
So,
ये वाला दे सकते हैं. चालू है.
Hello, nice session. Was there anything done around fine tuning of this VLMs like Qwen? Like if we compare Qwen with the abilities of say Gemini 2.5 Pro. So 2.5 Pro have good abilities of visual understanding, but let's say like if you go to Qwen, it's an open source. So the advantage it has is like you can fine tune it. So is there any experience around fine tuning ahead this Qwen?
So we haven't done that internally yet, fine tuning of VLMs etc. But what we have seen is a lot of other people are doing that, and like when Qwen was released, within few months they released all the recipes to fine tune those models. It's not just Qwen, there are a lot of other models. There is Kimi, there is I think multiple vision language models that have been around now from Meta as well, and you can easily go and do fine tuning. There is so much material out there to do that today. So you can even train on your own specific images and
our own training sets.
Right. It is possible. I haven't done that personally.
Okay, thank you.
So the examples that we saw, those were more of analyzing the data that we are giving, like summarizing or identifying the patches in the video which are doing certain things. So visual models are also responsible for generating the data, like images and the videos.
Those are different models. Those are generative diffusion models that can create something. Yeah, those are different models. So generative models are different. Those, like all the creators who are using to generate images and videos, those are different architectures. Some of those models also have ability to give your own video. So you give a video or image and say, I want something derived from this or inspired from this. Those models have vision VLM also like traces to it. Like they have some model underlying components that are also used there.
Because both the facilities will be required.
Right.
You
So
need to give input as a image or video and get the output as well.
So under the hood of these models, there are usually vision encoders and there are language encoders. And pre-trained, what they do is whenever they train their vision encoder, they use a language that is pre-trained model for language. So what these models essentially do is in vision space, they try to relate language objects with what they are seeing. They can understand, okay, this is a person. What does a person do? Person is born and then that person goes to school, etc. Model knows everything about that, right? In language. So whatever knowledge it knows in language modality, it starts learning to relate it in the vision modality. Similarly in sound and other different modalities as you keep training on those. And now most of the new models that are coming up as mixture of expert models. And within that then they have multiple models. So there are some generation pieces as well. And there will be somehow the generative pieces will be linked to the other pieces like understanding vision and language, etc. So what they can represent whatever the user has asked and then understand that in the using the image that user gave, etc., and then use that to generate something new. Initial generative models that we saw, they were like, give me prompt and I'll generate image. But now there are a lot of models that are able to like do this internally, like get an image, based on inspiration of that image, then create another image. Yeah. Okay, any other questions? Take care. Yeah.
So OCR versus VLMs. What I see is VLMs are able to infer everything that you see in and around, right? So in which cases do we really need to do fine tuning of VLMs? Can you shed some light around that?
So similar to regular LLMs in tasks related to language, for example, understanding some particular scenario and telling me which tool to use, or whatever you do with LLMs today, just the way you need to do fine tuning. For example, if a model is not able to understand your instructions very clearly or understand some tool use very clearly, then you would give it examples, right? It's also, either it is not really fine tuning, or it is more like just prompting, or if it is fine tuning, you are giving a lot of examples of, okay, in this scenario, do it like this. Similarly, you might have to build reliable applications using VLMs that work with a fair accuracy level, and that is when you will need you will need fine tuning.
So only for increasing the efficiency we would need to fine tune.
Accuracy.
Yeah,
accuracy. Yes. For accuracy, you would have to fine tune, because just like LLMs, these are generic models. They understand the world very well, but within the world, your corner of what you are trying to do, particularly, let's say you are trying to create something for carpenters, where carpenters use it and it will give them ideas on how to design new furniture, something like that. In that case, probably you will have to fine tune, because then can it understand all the trickeries and all the details that a carpenter is looking at? If not, how to give it examples so that it can go and learn that and at least use those examples to understand the visual world better.
Just one more question with respect to the latencies that are involved in this VLMs. So I was working earlier at Pinecone, and we used to help people, get more better at training and all of that sales all apart, right? Eventually, what we moved to is just based on the transcription-based model, right? So you record a demo, and then we'll transcribe it, and then based on that, we'll be able to showcase, how relevant did you speak and things like that. What was the level of confidence?
Audio transcription
and things around that. But even after LLMs and all of that came into picture, I've heard that people have actually started bringing in AI avatars who can act as your client, and then you can just do the demo and all of that. But still, with video coming into picture, there were some latencies involved. So what is your experience in, let's say if I want to create an AI avatar which just does all of these interactions, but what I've observed is there is a latency involved. So you cannot do just live-to-live interactions, just like how you are doing right now with
ChatGPT.
right? So there are latencies involved. So any experience, thoughts around how can we really get through this latency problem?
To be honest, we haven't solved that problem yet. What I have seen is most of these VLMs, they need a lot of compute, and there are options to do some like inference time scaling in terms of doing more compute so that you can stay real time and maybe keep processing as soon as the data is coming, etc. But there is still some inherent latency involved. It's not only about real time, it's also about how much time you need to process even one frame at a time. The promise that I have seen is, today ChatGPT did not work very well in terms of latency. It was still able to do everything, but with a little bit of latency. I have done that many times over, and the latency is usually 2 seconds, 3 seconds, which is fair enough. And with the newer model updates, I am hoping that that will go down, because a lot of robotics companies, their robots, their interactions are completely relying on real-time interaction. So I am sure you guys have seen already humanoid robot demos where humanoids are going and picking items. They are not even trained to pick items. They can understand this is a fridge. Within the fridge, okay, on the door side we usually keep eggs and all of that. They have all of that from their data, just like VLM and LLM trained data. So these robots, which used to take a lot of training, lot of proper coding to have them do anything specific, now they are becoming suddenly very generic in terms of, okay, just tell it, go and can you pick that trash bin. They go and understand, okay, that is trash can and there are 2 handles and I can lift from there. So all of that is coming from there.
I would like to share my insights to this question. So basically, हमने जब start किया था तो there was one protocol HTTP request. So the problem with that protocol was कि बहुत synchronous था कि आप request भेजो, आपको request आएगा, you have to wait for the request. Then came the web sockets कि real time में होता है. So now problem is कि when you are interacting with a model, you are sitting over here and the model is in US or somewhere. So to reduce the latency, like as you described, many companies are working on chips कि on device models run हो सके. So the device is processing on a device. Model is getting processed on a device.
So on the client side things are happening.
हाँ, तो वहाँ पे आपको कुछ issue ही नहीं आएगा. So ये एक चीज़ है मुझे जो लगता है कि
तो on the edge वाला processing is one solution, but आज VLMs की latency के अंदर में जो internet का latency है, so US to India, let's say example US latency back like both way is about 300 millisecond, but 300 millisecond is not your problem today because model में 3 second लगता है. So that is a bigger problem today. So there are people who are coming up with SLMs, small VLMs that are like just 1 billion parameter, 2 billion parameter. Within 1-2 billion parameter, they are able to do a lot of interesting things. And then you can always fine tune them. So they will give you much better timing when you put it on a like good enough hardware. So those are some approaches. And then of course, as we keep going in this direction, I'm like, just like any technology, I can clearly see that latency will get to negligent eventually. हाँ, right. So अभी क्या है कि image के अंदर में perception करके finally you have to like in LLMs they can give streaming output, right? तो वो streaming output आ रहा है. अभी vision VLMs के अंदर में भी there is streaming output, but जो input का processing है वो होने के लिए इतना सारा data एक साथ process हुए बिना कुछ होता ही नहीं, right? उसके बिना कुछ आ ही नहीं रहा. तो सबसे पहले so I think eventually ये सब problems तो solve हो ही जाएंगे. हाँ, what अभी आज ऐसा ना हमेशा वही टेक के साथ यही सोचो कि आज क्या पॉसिबल है, चलो वो करके तो यूज़ करते हैं. तो and people will solve next problems anyway. ठीक है? Yes.
Just a short question, like
Michael.
using these LLMs, as you mentioned, आपने वो वीडियो वाला भी हमें दिखाया. Can it calculate the distance? कि इतने मीटर पे ये ऑब्जेक्ट है, if we detect that object particular.
तो वेरी इंटरेस्टिंग क्वेश्चन. तो अभी जितने ये मॉडल्स हैं इनके अंदर में ये लोग नहीं कर पा रहे हैं. वन ऑफ द की important things for calculating distance is spatial understanding, right? And spatial के अंदर में हमारी आंखें जो बहुत कुछ कर पाती है, that is because of stereo vision. We have two eyes, right? Not one eye. तो there is a stereo vision और जिसके वजह से we have some sense of depth until some distance. मतलब यहाँ तक के तो कुछ डिस्टेंस तक के तो हमें डेप्थ का सेंस होता है, उसके बाद वो चला जाता है बिकॉज जितना आई का डिस्टेंस है उसके हिसाब से वहीं तक हमें डेप्थ मिलती है. सो लॉट ऑफ थिंग्स दैट वी आर एबल टू डू एंड डिस्टेंसेस वगैरह का हमें अंदाज़ा जो आता है वो स्टीरियो विजन की वजह से भी है एंड दूसरे विजुअल क्यूज की वजह से भी है. तो ओवरऑल रफ सेंस ऑफ डिस्टेंसेस दीज मॉडल्स कैन गिव यू, राइट? ये दो बिल्डिंग दिख रही है, इतनी दूर दिख रही है तो बताएगा कि इनके बीच में मे भी इतना डिस्टेंस होगा, राइट? बट एक्यूरेट डिस्टेंस मेजरमेंट एक तो उससे आएगा, जैसे अभी रेफरेंस कैलकुलेशंस आप कर सकते हो. पूरे सीन के अंदर में आप बोल सकते हो मुझे कार दिख रही है, ये कार फियाट है, ये वाला मॉडल है, तो तू बता सकता है क्या कि घर कितना बड़ा होगा ये, तो वो देखिए बताएगा. उसी इमेज में घर और कार दिख रहे हैं, तो कार अगर इतनी लंबी है तो मे बी घर उससे डबल साइज़ का दिख रहा है तो मे बी इतना होगा. ये वो रीजनिंग कर पाते हैं. लेकिन उसके अंदर में अभी जो प्रॉब्लम्स है, अभी वो स्केल से आप मेजर करने जाओगे तो वो नहीं आएगा, उतना नहीं आएगा. बट जितना भी वो लैंग्वेज में कुछ तो कन्वर्ट करके सोच के ऐसा रीजनिंग करके बता पा रहे हैं, वो सब चीज़ें वो कर पाते हैं. इंसान भी तो ऐसा देख के थोड़ी बताते हैं 1 मीटर डिस्टेंस है, अंदाजे से बता सकते हैं, एक्यूरेट नहीं बता सकते. एक्यूरेट करने के लिए यू नीड अ मेजरिंग टेप. तो वैसी चीज़ें लाइक दैट इज़ वेयर आई थिंक द स्टेट ऑफ द आर्ट इज.
जूम इन जूम आउट भी वहाँ पे मैटर करता होगा ना?
हाँ, वो सब मैटर करता है. कैमरा का एंगल क्या है, आप टॉप व्यू से देख रहे हो, सामने से देख रहे हो, वगैरह वगैरह सब मैटर करता है.
So let's start with the next session where we'll go into how we are kind of using VLMs at flight base and what are the different capabilities that we have built. So I'll quickly start with the problem statement first, what we were trying to solve, and then we'll go into how we went about solving it. उसमें फिर क्या challenges आए, क्या what were our learnings, ultimately what worked, and in the process of that what didn't work as well. So overall, at Flightbase, everyone who uses our product, they capture a lot of multimodal data. So, like every day, if you have a docking station and if drones are flying around, they will capture a lot of video. Like every flight is around 20, 25, 30 minutes of, and पूरा flight जब record होता है, that is like a 30-minute long 4K video. And these flights are being done of orders of like 10 to 20 flights a day. So you can just imagine the amount of data that they are capturing just in one day. Across a month, this is like thousands of videos. So next biggest challenge that a lot of our customers and partners were facing is, अब ये data देखेगा कौन? They will have to set an army of people just to look at that data and figure out कि अरे जो भी मैंने capture किया उसमें से end result निकलेगा कैसे? And that is where we kind of thought that okay, VLMs are a very good fit for this kind of use case, because if VLMs are able to understand the video and let's say from terabytes of data, just give me, okay, these are the 10 actionable points in the video that you just need to look at, rest of the video is fine. That just reduces the amount of time I have to spend on a particular data or a particular flight from probably looking at a screen for 30 minutes to just quickly getting it within a minute and move on. So that was the, on a very high level, the problem statement that we wanted to solve. So we'll just do a quick demo first of what we were ultimately able to come up with, and then we'll go into the process of how we got there. So as you can see here, so this is an 8-minute long flight at one of the farms that where the docking station is deployed. And now for anybody to look at, so there are a few incidents that have happened across this flight. Like what is important to them is there was few vehicles that were spotted. So you can see right now there is a this one here. There's a very so this is from a very long height. So you can see that's a motorcycle here. There are few instances where the plant's health is not good. There are few instances where vehicles were detected, and so on and so forth. Now these are all incidents or kind of events that are important to the customer. But to get to this, they'll have to look at an entire 8-minute long video. What we're able to do using VLMs is segment this out by sections and actually come up with, okay, so if you look at human presence, okay, from 27 seconds to 31 seconds, that's a 4-second window, you have a person that is being spotted. Again, from 44 seconds to, yeah, so these are the kind of events that we can extract out of this video, and now nobody has to go and look at that entire video. You just look at the events that you are interested in and just move on. So this is the kind of analysis that is possible right now using VLMs.
Okay, so let me take you through the journey of like, that was the first kind of MVP that we wanted to create. Second one was actually giving it a feel of live detection. SRV, mic. Sorry. So, okay. So in second, what we wanted to do was live transcription and having the knowledge of what is actually having in the video. So what happens is usually the day-to-day videos does not have any incident or anything. So we tried with a lot of compilations, to be honest, what is happening and what is not. So the first video was actually some sort of a demo which was giving you a feel of post-processing. Once the video has been captured, then the analytics will happen, and then you can have whatever you seems necessary. You can put that thing up and do this thing and churn this kind of data out. But in second situation, let's see if you have something like CCTV. So during live events, you need to have alerts, or even the security personnel want to know like what is going on right now or what has happened on the previous things. So I think everybody is too focused on the video, so let me pause it for now. So we tried doing this with compilation so that we have a lot of event and we were able to see like how much the VLM is actually capturing this thing out. So let me take you through the process of what happened and what kind of things we have used and what kind of results we have got. So first is quite simple. We started with Qwen. Qwen was something which is not readily available for videos as of right now. It is more of processing with images. So we went ahead and deployed our own. So there are like 2-3 platforms that we use. Paddle was something we were trying to use, but it is Chinese, so it was not that user friendly. So we went ahead with Vast. Again, Hugging Face had that model, and we were able to actually kind of deploy it out, but the performance with your own deployed model is not as same as like the APIs that you use. So we had a really bad experience about the time frame segmentation. Like Qwen models showed that there were a lot of things that they can do, but what we kind of found out was they were like a little bit inconsistent. Like even if you give a long video, it usually gives you time frame within just 5 minutes only. I don't know why that was happening. So we went ahead with 12 labs. So anybody knows 12 labs? So yeah, 11 labs is actually for voice. 12 labs, acha, I haven't opened 12 labs. So 12 labs, what they do is they do video embedding. So the product that they use is the product actually gives you a feel of like encoding of the video itself. So they have small kind of embedding of your whole video, and they can actually provide you insights of that video, what we were trying to do. But
just one second. Few things on that. So initially when we were using Qwen, our entire approach was, alright, for this end goal, what we'll do is we'll use Qwen to transcribe the video as it is. So it generates like, let's say 5-second summaries of an entire 8-minute long video. So that's like 12 into 8. So those many kind of summaries. And then we'll do search and etc. across that to kind of get to exactly events that the user is interested in. So that was kind of our first approach, which we tried with Qwen. We also then looked for different models. So tried Gemini 2.5 Pro at that time over there. So, but what we thought was there was like a fundamental difference in our approach, where what we as humans, like what I see visually, I'm converting that to text form. Now text will not have the kind of richness that actually what I can understand directly from video will. So our initial approach where we were converting video to text and text to an embedding on which we were trying to match. So all of our search was in the text space and not necessarily giving the ability to search on video. Once we transcribed our video to text, we lost a lot of insights that are present in the video but no longer part of the text. Like in the, if you can show the first video. Yeah, if you can see here, based on the prompt that we had to kind of transcribe this text, it used to capture those specific things. Like if I had specifically mentioned in the prompt, okay, look for people in this video, or look for areas where there is flooding, or look for where you don't see a lot of growth in terms of, because this is a farm kind of situation. Now the transcription only picks those events. Now let's say I'm interested in, okay, find out all where there is a road crossing. Now that is not part of the transcript. So the process of getting from video to transcript, I have lost that information. And that is where the kind of tools like 12 Labs, what they are doing fundamentally is they will take your video and convert it directly to embedding. So they have done a lot of interesting things in terms of video directly to embedding, and similar models are able to convert text to embeddings as well in the same space. So with those kind of tools, we are able to convert video as well as text into the same vector space. So now I can search on that. So in that kind of an approach, I don't lose out on the context of, okay, there is a road crossing here. So that was kind of our hypothesis, and then we kind of thought, okay, let's do an experiment with 12 labs. So yeah, I'll show that.
okay, so we started with 12 labs. So here you can actually just go out and search. So as Amok told us, so these guys can actually have a bunch of your videos. They will index everything, and you will be able to perform searches into this. But again, like what Amok told us, they can actually show you like crossing and everything, and they can re-index things again. But main problem with them is they are not thinking over here. They are more of a static model. So the embedding work that they have been doing is great in video side, but apart from that, whatever the LLM side which needs to have been evolved in way more sense than what they have done is kind of lacking in 12 labs. So we started with using their embeddings, but it again started doing a bit of weird things. So let me give you an example. So how many of us know what embeddings are, to be honest? So embeddings are just like points in multi-dimensional spaces. So if let's tell you what's the closest point, even if it's 180 degree behind you, you might find it like that's the closest point, but that's not relevant. That's what Labs does. That's how their embedding works. They give you the closest things that you want. But if you, let's say, want to have something like, tell me wherever yellow car is present. So that is way easier for them. But if you want to ask them a question, this incident happened, but what car did actually did this thing? What kind of things that, so these kind of questions which are like kind of direct toward an agentic system is something that 12 labs cannot solve. So we kind of again reiterated and went again with the transcription approach only. So this is like the second demo that we did where we wanted to have a kind of a live kind of an experience. So here also we went ahead with two-layer kind of event detection. First with 5-second kind of transcription of the whole video or even like the analysis of the video itself. And after second pipeline used to actually take out the events out of it. So we have a bit of overlap between how much videos we are giving to Gemini to process, and using that we were able to create a kind of a transcription of the whole video, and then we started embedding that thing again. So again with our own embedding, the same problem came in. Like we can easily go ahead and do this thing, where is the yellow car, but we cannot ask them questions as of right now because that will give us like the closest vector and nothing else. For full video embedding, what we started with was 5-second transcript of the whole video, which was understood by Gemini. This thing was then post-processed to actually create and merge the events out of it. Then these events was stored into Weaviate, and that's all, to be honest. There are like pre-processing thing. If your video is too large, you might need to chunk it. If the resolution is too high, you might to reduce it down. Usually 1920, 180, 1080 works good with these kind of things. So that's all. Interact is something we kind of made things out of our own. We made the whole UI, and for APIs, we have the APIs for video. APIs for chat. These chat we have Weaviate APIs going on. Apart from that, the whole video is coming through a CDN. So
we're chatting with the LLM,
yes. So what happens is यहाँ से जो transcripts निकले, right? Now this chat, there is a LLM that you are chatting with that has access to the database जिसमें ये सारी chats रखी हुई है. So based on what you have asked the LLM, it will query the vector database for relevant chat sections, and then उसको process करके it will give you the output. This video is pre-processed, and for these alerts, जो भी vector database में गया, there is a separate pipeline that processes all these chunks in serial order to generate these alerts. It is a pipeline on that track which generates this alerts.
So on engineering side, like, is there any specific vector DB that you preferred over like other vector DBs? Because there are like multiple vector DBs nowadays, even Postgres. So can you tell us like which one you preferred and what?
I think Amu can answer this thing better.
So again, I think what I mentioned previously as well, we focused more on which embedding model would suit. So we kind of even did PQ research on so many times when these embedding models get released, they kind of share examples of what data their models work best on, etc. So that choice is more important. In terms of for us, this was more of a proof of concept and a demo application that we were building. So we didn't really need to look at more in terms of scalability, etc. of the database. In terms of purely storing embeddings, I would kind of recommend go with enterprise grade ones. Like Mongo has nowadays started doing that. Postgres does it as well. So they are better in terms of reliability. But again, the embedding model I think is more key over in that process, not necessarily where you're storing and where you're querying from. That is more of a deterministic system. So that is like a lot of people have solved it in that form.
But वैसे तो Qdrant, Pinecone, Weaviate इनके भी तो अभी काफी अच्छा traction होने लगा है. मतलब there are production use cases.
Pinecone is the first vector DB that pops out whenever somebody talks.
S3, we have it.
S3 with vector.
S3 has come up with vector search on their storage, but very recent. Again, our focus was not on what model, because in our case the videos are so specific. Like पहली video मैंने दिखाया था, that person is so small. The model should be able to identify that and place it in a vector space that is easier to query. If everything just looks the same, so then I can't search anything.
We have a hands-on session as well.
We have one. So this is the code. Like if you guys can just scan it up, I have a small script of Weaviate. It's basically that.
You would need to
put it into laptop.
URL भेज के download
URL पे
URL बना देते हैं. या शॉर्ट कर दो ना, बिटली से शॉर्ट. नहीं ये छोटा सा ही URL है.
So
it will be a Google Drive link.
So there is a zip. I have even put the APIs key for you guys right now. So please don't bankrupt us. I will actually revoke them after this session. But this is a simple like Weaviate CLI client. We have used Weaviate. So I have like the version you guys have won't have like filters, to be honest, because I was not able to implement that thing like in 20 minutes while Dheeraj was giving his presentation. So this CLI tools actually, so ignore the volumes. So this CLI tools actually let you query our database or this system. So one thing that I can tell you is this endpoint is barely related to anything agentic. This is pure RAG. So this is more understanding of why using normal RAG is something not advisable. So somebody can name a song for me or a lyrics of a song.
Touch base.
ठीक है चलो. कोई सा बता दो. चलो हाँ don't to search करते हैं. So this is what actually is a problem with RAG. So I haven't put a limit on anything. This will give you result every time, whatever gibberish you.
So essentially क्या होता है अभी ये vector it is like a DB query, right? And because ये सारा comparative है, it does not know what comparison beyond which ये irrelevant हो जाता है. For it, if you have 100 entries in your database and you ask it to give me nearest 100, always all the data. सब कुछ दे देगा. It doesn't really know what is far, what is too close, what is too far. वो वाला concept. इसीलिए whenever we have such queries, ये सब एक आगे it goes into another pipeline, which will filter all of this out, see what is actually relevant, not relevant. So database high level.
We had a running joke inside of a team, like everybody was creating RAG. So first step to actually create a RAG is to ask yourself, do you need a RAG? Because at most times you don't need a RAG. Your DB will suffice with it. If you have IDs working around and you have a good normalized database, it will actually work out fine even with LLMs also. You don't need a RAG always. So that is one thing that we have learned in hard way. Apart from that, this was something I have a script of which you guys can get. But let me give you a glimpse of. I think I closed. Yeah. So this was like a little bit of glimpse of on what we are going to do in next session. So this is line flow. We will go deep into it in next session. So this is actually a rack system which we use as of right now.
So we'll kind of go deep into when we spoke about, okay, we have pre-processing pipelines. After we query the database, we have another pipeline that runs, which kind of analyzes, does a lot of agentic systems based on that. But we'll go deep into that next session and what those pipelines are, why they are, and how they are made in kind of this in Langflow and similar such tools.
So
okay, anybody able to set up
this thing? So that thing is both Python and Docker setup. So there is a README if you guys want to go through it.
So if you have any container setup, it can run in that mode as well as like a simple patch system.
नहीं उसके बाद वो skip advertisement करना इसका वो Google Drive से लिंक है उसका दी हाँ
Alright, meanwhile, any other questions?
Any challenges you are facing currently in this setup?
So in this setup, like in terms of like next things that we have to do, we have to get to actual live event detection. So right now what we are able to do is we are able to process larger videos, but kind of the entire engineering behind running it as you are getting a live RTSP or a WebRTC stream. So that kind of engineering piece is something that we have to do next. And apart from that, I think one thing that we have to again think of is smaller VLMs that are more specifically tuned for our use case. Like right now we are brute forcing it with like very large models like Gemini and other kind of models that are hosted. The issue with that is they are very, like what Dheeraj also shared, right? They are slow in responding. Like to get a 5-second chunk out, I'll need to spend 15 to 20 seconds in an API call. That kind of live it starts to create problems. But if we kind of experiment with things like smaller 1 billion, 2 billion parameter VLMs that are specifically trained to look at the things that we want to look at, then that will give us better performance in real time. So those are like kind of few directions that we want to go into.
So as you told, you are processing the video in 2-3 different steps, like first converting to chunks, then generating vector embedding, then again your prompt will go into a vector embedding, then the search, then again the similar embeddings will go into another pipeline. So there is a lot of steps in this. So how are you currently trying to make it a cost efficient, or you are just focusing on the output?
Right now, a lot of focus on accuracy, so that we can generate value in terms of show that this kind of a system can actually generate value and it can actually, because ultimately if the result is not good, then it is not useful. So primary aim is yes to get a good result in this, because there are two directions that we are kind of betting on. One is LLMs, VLMs will keep getting better. So that is one place from where our accuracy will improve. And apart from that, through fundamentally the concept of fine tuning and smaller models, we will be able to get the engineering of it sorted. So we are giving demos with this. Yeah, I would not say exactly in production where users are using it hands off.
But there's something else that you're working which has gone
to production.
Using VLMs.
That one is using LLMs itself. So with VLMs, these are the two things which we are kind of giving demos here and showing you.
Any thoughts around challenges around observability of these systems?
Probably something that we'll take up next session again. So with Langflow, there are tools like Langfuse and all which help with observability of the entire pipeline.
That's the topic of next session.
There is the link if in case you want to type in there and I can make it down. So yeah, you will put in some. You can only come here and
Yeah, you can come here.
maybe I will assist you. Everybody can learn. You have a read for that. क्या करना है?
Okay, so we have a Python setup over here. So so we just have to go Weaviate. We have to like write a query for us, and we can search for a term. Let's say whatever we want to search. Like this cafe. This will give you a lot of provisions. So that's the process. But if you want how RAG works is this demo actually shows you how RAG works and how it's not agentic as such, how to work around it and what you can do. So that's why this thing was created by me.
So well, let's try to search something relevant. Like let's search blue bus for example. I can see one is here, but let's see what else it is able to find.
Let me limit out this thing. Build.
So in this output, what you can see, right, the time frame, video, description, this is all that VLM is generating. So these are all those 5-second chunks. So based on the system prompt, this can be like 1 or 2 lines or even as big as it can spread out like 50-60 lines based on all the details that are there in that. So what we have done here is in Weaviate, which is the vector database, this key, which is time frame video description, is the only key that is vectorized. Rest of the things like the video ID, time frame, etc., that is all just like standard database entry that has gone through. And now, once this embedding is done, internally we also generate an embedding for the query. So Blue Bus has its own embedding that was generated. And now these are matched to find out, okay, what is the closest 5 entries. So now that is what we can see here. Abhay, we can open one of these videos if you want to, or probably we want to check. Yeah.
Sorry for that. But again, there are like more concepts around RAG. We have graphical RAGs and everything. Again,
This is just a RAG. It's not agentic.
This is not agentic. This is essentially like a new age DB query is what we are doing. Previously, we in database queries used to like match exact. The entire thing had to match. Right? पूरी string match होती थी या पूरा key match होता था. Now this is more in terms of when you are working with probabilistic systems like LLMs. You read this. This is like आज के दिन का नया database है.
Agentic RAG होगा तो क्या करेगा फिर?
What agentic RAG would do is based on this data, you will have another LLM which will process this data. It will see, okay, do I have enough information to satisfy the user's requirement? If no, it will adopt the query, perform that query again. It is kind of searching multiple times with different, it's trying to search across different angles multiple times. So like LLM in front of this would probably query this like 5 or 6 times. I have asked it for a blue bus. It will probably start searching with bus. चलो कार भी ढूंढता हूँ, कुछ कार में relevant मिल रहा है क्या? Blue color में और क्या है? वो सब it will search across all of these aspects and then give a more natural language based response. This is just a database query, so this is more like a internal JSON kind of response. And those LLMs can then actually do a second order, third order reasoning on this kind of data. Simply just having a vector DB से वो reasoning वाली ability नहीं है.
How different will be the approach when we have VLM?
This also has VLM. This is like VLM is being used to generate all of this description actually from the video.
Even after if you have like an agentic RAG instead of LLM, you can use VLM over there. But The additional part is you can even provide chunks to it. But that is something that we haven't used. We haven't used VLM inside of our agentic side, we have just used LLM as